Welcome to week 8. This is our video lecture for chapter 5, Introduction to Valuation, the Time Value of Money. There are multiple topics in the chapter: time and money, future value and compounding, present value and discounting, and then a more in-depth discussion about present and future values. First, we're going to talk about time and money. I'd like to emphasize that the single most important skill for a student to learn in this course is the manipulation of money through time. This is key. This is a core learning objective for the class. You will use it in multiple areas, and you will see how it plays out in terms of financial planning as well as project evaluation and assessment. We're going to use a timeline to visually represent items over time. So we're going to start with a very simple example, fruit. Yes, some fruit. So if I give you apples, one per year, and then you can easily conclude that I've given you a total of 3 apples over a period of 3 years. So visually, this would look like this: apple today, apple at 1 year, and an apple at 2 years. However, money doesn't work this way. If I gave you $100 each year, how much would you have in total? Give you $100 today, $100 in 1 year, and $100 again. I give you at 2 years. $300. Is that correct? The answer is no. It's not correct. The difference between money and fruit is that money can work for you over time, earning interest. So let's take a look at another example. Which would you rather receive, A or B? $300 today, which is A, or B, $100 today, $100 in 1 year, and $100 in 2 years. If we look at the choices, we can see that they are different over time. However, A is better because you get all the $300 today instead of having to wait 2 years. Receiving money 1 year from now or 2 years from now is different than getting all the money today. So if we go back to the fruit analogy, receiving money over time is like receiving different fruits over time. Remember this, that the fruit example is qualitatively different, but the money example is quantitatively different. There is still a fundamental difference in the items received over different time periods in the future. And the key is in finance, you don't mix fruits. So anytime you see money spread out over time, you must think of the money as different. You can't just add it up. It just doesn't add up 1 plus 2 plus 3. You must look at it as different entities. So money received over time is not equal in value. The question then is, how do we value future money in terms of making the amounts equal? The way we do it is by present and future value. Present value is earlier money on a timeline. Future value is later money on a timeline. The interest rate is an exchange rate between earlier money and later money. Interest rate is also known as discount rate, or the cost of capital, the opportunity cost of capital, and the required return or required rate of return. So these are all synonymous with interest rate. Future values are similar to present values. What is the future value of $1,000 in 1 year? At 5%, it would be $1,050 if we invested it for 1 year at 5% per year. And we can figure it out using this. 1,000 times 0.05 is 50. So the value in 1 year is the principal plus interest. So the future value is $1,050. And suppose you leave the money in for another year. How much will you have 2 years from now? Future value then is 1.05 times 1.05, or 1.05 squared times $1,000, which is 1,150 cents. Actually, it should be 50 cents. So we have a general formula for future values. Future value is equal to present value times 1 plus the rate to the t power. Future value is FV, PV equals present value, R equals period interest rate expressed as a decimal, and T equals number of periods. This gets a little tricky when we talk about monthly interest versus annual interest. And we will see a little bit later that the compounding period is very important in determining future value. 1 plus R to the T is the future value interest factor. This determines the exchange rate between present value and future. There are multiple ways of compounding. You can have simple interest or compound interest. If you look at the previous example with simple interest, the future value is 1,000 plus 50 plus 50 is $1,100. But a future value with compound interest is $1,102.50. The extra $2.50 comes from the interest of 0.05 times 50 equals $2.50 earned on the first interest payment, or interest on interest. This is why compounding is so powerful, because you earn interest on interest. So suppose you invest $1,000 from the previous example for 5 years. How much would you have at time 5? You would have $1,276.28. The effect of compounding is small for a small number of periods, but increases as the number of periods increases. This is very important. Just remember that the compounding effect is smaller for a shorter time and smaller number of periods, but increases as the number of periods increases. So suppose you had a relative deposit $10 at 5.5% 200 years ago. If we look at this on the timeline, how much will you have today? If you look at our future value equation, you would have $447,189.84 today. And this is all due to 5.5% compounding. What's interesting about future value is also as a general growth formula. It works for money, but it works for other variables, like bacteria, the growth rate of bacteria, housing, the growth rate of housing, epidemics, the spread of epidemics, and production, the production function. So let's take a look at the example for the production function. So suppose your company expects to increase unit sales of widgets by 15% per year for the next 5 years. If you sell 3 million widgets in the current year, how many widgets do you expect to sell in the 5th year? Again, this is an example of compounding. So this would be at 5 years. Well, this is shown as a calculator calculation, but it would be about 6 million units. One of the important topics here in this chapter is present value and taking future values and discounting them to the present. So if we can go forward in time to the future using compounding, then why can't we go backward in time to do the present value? But we can. Finance uses the process of moving future funds back into the present when we value financial instruments like bonds, preferred stock, common stock, and other financial instruments. We also use it to evaluate investing in projects, and for this class, this is why it's important, because you're going to be doing some project assessment, so you need to look at the time value of money in project evaluation. What we're doing, of course, if you visualize this on a timeline, is going from a future value back to a present value, moving the opposite direction. So one of the keys here is the questions that we're going to ask. And so the first question, how much do I have to invest today to have some amount in the future? That's a future value. So when we rearrange to solve for present value, we see that present value is equal to future value divided by 1 plus R to the T. So when we talk about discounting, we mean finding the present value of some future amount. When we talk about the value of something, we're talking about the present value, unless we specifically indicate that we want the future value. And finance uses compounding as the verb for going into the future and discounting as the verb to bring funds into the present. This is compounding. and this is discounting. So let's take a look at an example. Suppose you need $10,000 in 1 year for the down payment on a new car. If you can earn 7% annually, how much do you need to invest today? So this is a present value question. Let me use our present value equation to come up with the figure of $9,345.79 at 7% annual interest. You can just ignore these calculator functions because we're not using a calculator for the class. We're just doing it longhand with the equations to become familiar with the concept. So if we look at this on a timeline, what we can see is that we are discounting $10,000, the future value, back to present value of $93.45.79. Here's another example. You want to begin saving for your daughter's college education. You estimate that she will need $150,000 in 17 years. If you feel confident that you can earn 8% per year, how much do you need to invest today? So again, this is a present value question. We look at the future amount of $150,000, and we're going to discount it back to today to get a present value. So the present value then is $40,540.34. This is what you would need to invest at 8% over the annual compounding, 8% per year compounding for 17 years in order to get to $150,000. Here's another example. Your parents set up a trust fund for you 10 years ago that is now worth $19,671.51. If the fund earns 7% per year, what was the initial amount of the fund? Again, this is a discounting. We look at the future value, $19,671.51, and then we discount it back to the future, to the present value, which happens to be in the past, but it's a present value problem, so it's $10,000. So these are some important aspects of the present value relationship. For a given interest rate, the longer the time period, the lower the present value. So the more time we consider, the more the effect of discounting. So what's the present value of 500 to be received in 5 years, 10 years? The discount rate is 10%. So for 5 years, the present value is 310.46. But for 10 years, it's only 2/3 of that, about 192.77. So we can clearly see the longer the time period, the lower the present value, holding the interest rate constant. The second relationship is for a given time period, the higher the interest rate, the smaller the present value. So what's the present value of $500 received in 5 years if the interest rate is 10% or 15%? At 10%, it's 310.46. But at 15%, it's 248.59. So we see a much greater effect of discounting. So there's the basic equation. Present value is equal to future value divided by 1 plus r to the t. Present value, future value, r, and time are the 4 parts to the equation. So if we know any 3, we can always solve. Let's talk a little bit more about present and future. The discount rate is very important because many times we're going to want to know what the implied interest rate is on an investment. So we rearrange the basic present value equation solved for r. We can see r is equal to future value divided by present value to the 1 over t minus 1. Here's an example. You're looking at an investment that will pay $1,200 in 5 years if you invest $1,000 today. What is the implied rate of interest? R, again, is 3.714% using our equation. Here's another example. Suppose you're offered an investment that will allow you to double your money in 6 years. You have $10,000 to invest. What's the implied rate of interest? Again, 12.25% using this is the calculator calculations, but we can just as easily use the equations. This is very important because then this enables you to choose among different investments that have different rates of interest. It also enables you to cut through the BS associated with many investment opportunities. Here's a third example. Suppose you have a 1-year-old son and you want to provide $75,000 in 17 years towards his college education. You have currently $5,000 to invest. What interest rate must you earn to have the $75,000 when you need it? So again, this is the future value problem. So the present, we look at our present value, future value equation, and we see that we must earn 17.27% in order to get to our goal. Here's some finance formulas. You want to remember these. PV, present value, is what future cash flows are worth today. FV is future value, what cash flows are worth in the future. R is the interest rate, the rate of return or discount rate per period. Periods are typically, but not always, 1 year. And the T is the number of periods, typically, but not always the number of years. And C is the cash amount. So the future value equation we looked at before is right here. Future value is C times 1 plus R to the T. And the term 1 plus R to the T is called the future value factor. That's for compounding. And also the present value of C, we'll use it. We use the same equation. Present value is equal to C divided by 1 plus R to the T, where the term 1 over 1 plus R to the T is called the present value factor or the discounting factor. And the basic present value equation, giving the relationship between present and future value, is shown here on the bottom. So know these terms, what they mean: future value, present value, compounding, discounting, simple interest, compound interest, discount rate, the required rate of return. And know these equations. Use some of the examples in the book. I'll be giving you some in the study guide, so you can take a look at some of those. But learn how to work with these so you can solve for any one of these variables. So what are the most important topics of this chapter? Time changes the value of money as money can be invested. It's not simple additive. It's actually exponential. And so we see the two approaches are compounding and discounting. Money in the future is worth more than money received today. In other words, $100 in the future is only worth maybe $75 if it's discounted back to the present. So money received in the future is worth less today because of our present value. So it's actually saying the same thing. The interest rate, or discount rate, and time determine the change in the value of an investment. So questions about this, please post them in the Q&A threads, and we'll see you in the class shell.